Space, the final frontier. Come with us as we explore and unravel the mysteries of what lies beyond our planet Earth. Strap yourself in. Get your spacesuits ready as we prepare for takeoff in T-minus 5, 4, 3, 2, 1. Welcome to Inside Outer Space. Solar System. Now let's talk about the solar system. The Sun, our planet, our moon, the other planets and even their moons. They all make up the solar system. The solar system is a gravity-bound system that is comprised of the Sun and the objects that orbit it, hence the name. Because of the Sun's large mass, it exerts gravity or the force that attracts objects. This force keeps the planets and other objects, such as asteroids and dust, to keep a steady orbit or a path around the Sun. This movement around the Sun, coupled by the rotation of the planets in orbit, is what causes night and day, as well as the changing of the seasons. One whole rotation for planets is called a day, while one whole cycle around the Sun is known as a year. And for the Earth, that's 365.25 days. Other planets have varying distances around the Sun. Therefore, a year for these planets vary according to distance. So one might ask how the solar system began. Well, this is one of the questions that scientists have been trying to answer for years. There is of course a lot of interest in this topic because knowing about the origins of the solar system can help scientists better understand the origins of our own planet Earth, and subsequently how life originated here as well. Here's what we have so far. Scientists believe that the formation of the solar system took billions of years in the making. In the beginning, the solar system started from a giant cloud of dust and gas. As the clouds and dust grew more massive, it began to collapse on the weight of its own gravity. Because of its own gravity, this mass started to move in a giant circle, spinning faster and faster as it collects more dust and gas. And then a star started to form. It grew as it sucked in more dust and gas, eventually igniting and turning into what we now call the Sun. The Sun grew and began to blow solar winds, which pushed some of the remaining gas and dust outward. These gas and dust debris eventually formed into planets and moons. Planets closer to the Sun had the solar winds blow off more of the excess debris, making them smaller than the planets which are farther away from the Sun. There are 8 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But there are also hundreds of smaller bodies, such as moons, minor planets, and asteroids, which are also kept in orbit by the Sun, and therefore are as much a part of the solar system as the planets. As for humans, well, we have been sending satellites and probes for decades now, since the 1950s. And we are still barely scratching the surface of planets that are beyond our own. Satellites. Satellites are the objects circling around a planet or a star. They come in many different forms and sizes, and some objects most of us think are not satellites actually are satellites too. The Earth, for instance, is a satellite because it orbits around the Sun, a yellow dwarf star. The other planets are also satellites because they also revolve around the Sun, and each planet, except for Mercury and Venus, have their own satellites as well, their moons. The Earth only has one, but the other planets have as many as 60. But the planets and their moons are what we call natural satellites. Those things we see seemingly floating in space are all man-made, or what we call artificial satellites. Artificial satellites are going to be the focus here because they do more than just float in space. The first man-made satellite in space was Sputnik 1, launched by the Soviet Union in 1957. The following year, the US launched its first satellite, the Explorer 1. Earth's first satellite photo was taken in 1959 by the US Explorer 6. Launching satellites have changed how people perceive the Earth and the outer space. Artificial satellites provide a bird's eye view that allow them to gather more useful data at once than telescopes or merely studying on the ground, which is why there are thousands of satellites in space, mostly stationed around Earth, to take pictures that could help predict weather and track incoming storms and hurricanes. Some satellites are sent to observe the Sun, other planets, and other objects that exist beyond the solar system. It's because of satellites that we know the Earth is mostly blue, with huge green and brown pieces on its surface and swirling white gases all around it. We learned the existence of Saturn's many rings or Jupiter's great red spot all because of satellites. Through satellites, we can also be warned of approaching meteors that could crash into Earth or be more aware of dangerous sun rays. Many satellites are sent to orbit different planets, stars, and other celestial objects for further studies. Satellites also play a big part in communications. TV, telephone, and internet signals wouldn't have reached and connected people from longer distances if there were no satellites. Because before, signals were blocked by mountains and tall buildings, and telephone wires over long distances were hard and expensive to set up. Now, signals are just being sent upwards, and satellites send them back down to wherever the supposed recipients are. Satellites have different models and designs, but a lot of them have at least two parts in common: an antenna and a power source. The antenna delivers and acquires information, usually to and from the Earth. The power source could either be a battery or a solar panel. But wait, if they are not really celestial objects, then how do they get into space? Well, satellites are launched into space by rockets. The acceleration of the satellite due to the rocket launch decreases due to the pull of the Earth's gravity. Each satellite sent out to space orbits Earth at different distances, speeds, and paths. There are two common orbits: geostationary, which travels to a west to east motion, much like how the Earth rotates. That's why satellites in this path look like they don't move at all. The other orbit is polar, which travels to a north to south motion. It's necessary that all satellites are on different distances, speeds, and paths to avoid collision with other satellites. But this prevention gets increasingly difficult if more satellites are launched into space. Earth, the third planet from the Sun, coming in with a diameter of 12,756 kilometers, or 7,926 miles, and a mass of 5.97 times 10 to the 24th power kilogram, or 1.3 times 10 to the 25th power pounds, with one moon, and an orbit period of 365.24 days, with a varying surface temperature of -88 to 58 degrees Celsius, or -126 to 136 degrees Fahrenheit. It's the planet we call home along with 7 billion other people. Welcome to Earth. The Earth is the only planet in the universe that does not have a Roman or Greek god's name. Its name comes from the old words like Eorde, Gaia, and Terra, which means world. The Earth's atmosphere is 21% oxygen, or the stuff that humans need to breathe. It remains to be the only planet which has 2/3 of its surface covered in liquid, or the water that makes up the Earth's oceans. This planet is also covered in solid rock plates that float on a hotter inner layer of molten rock. This is why there's volcanic and seismic activity in the Earth. The Earth has a tilt in its axis. This makes seasons throughout the year possible. The tilt makes some regions of the Earth receive less sunlight and warmth, thus directly causing regions in the northern and southern hemisphere to experience winter and other seasons. Telescopes. Before there were satellites, a long metal tube with mirrors and lenses is what we use to look at celestial bodies. A telescope. Telescopes go way back as far as the 17th century, when a patent of the first telescope was submitted by Hans Lippershey to the government in Netherlands. Although the actual inventor was unknown, the first version of the telescope was composed of a convex objective lens and a concave eyepiece. Galileo heard about this patent and decided to build his own version. Galileo proceeded to be the first person to point a telescope skyward, and he was able to make out mountains and craters on the moon's surface, despite the telescope being small and the images too fuzzy. Galileo's telescope was also the first one to observe the Milky Way galaxy. Of course, during that time, he hasn't realized that yet. Using his own version of the telescope, Galileo was also able to identify Jupiter's 4 biggest moons, collectively known as the Galilean moons: Ganymede, Io, Callisto, and Europa. The technology of telescopes has greatly improved after Galileo and Newton's time. The telescopes are now bigger and more complex. This enables astronomers to discover faint stars and calculate stellar distances. In the 19th century, a new instrument called the spectroscope became popular. During this time, astronomers were already able to identify the chemical composition and motions of heavenly bodies. From there, telescopes became bigger and bigger and went on to become specialized instruments that could look into further distances in space and time. But of course, despite having the most advanced telescope mounted on the ground, it is not invincible from the atmosphere's visual tricks, which is why in the 1940s, astronomer Lyman Spitzer dreamed of having an observatory in space, positioned above Earth's atmosphere so that observations would be more accurate and the view would be sharper. So, in the 1970s, NASA and the European Space Agency, or ESA, collaborated to design and build what is now called Hubble Space Telescope. In 1990, 5 astronauts boarded the space shuttle. The Hubble Space Telescope was deployed in an orbit around 300 miles or 482.8 kilometers above the Earth's surface. The images that the Hubble delivered was more than expected. This space telescope symbolized the accomplishment of a 50-year-old dream and decades of hard work and collective effort of scientists, engineers, contractors, and institutions around the world. Of course, today, space and aeronautics agencies also now heavily rely on satellites because you can also launch them into space and send them to greater distances and get a closer look on stars, planets, and other objects. However, telescopes are still widely used for space and aeronautic studies. If you're very much interested in space, but you're not a part of NASA or any space organization, a telescope is your friend. You can look for moons, other planets, or stars just by sitting in your balcony or your backyard at home. Neat, huh? Stars. Stars are perhaps the most recognizable celestial bodies in space. Even without studying astronomy, most people would be able to identify what stars are. But stars are more than just sparkly things in the sky. They are made of plasma, the only one among the 4 fundamental states of matter that does not exist naturally on Earth. The reason why they shine and look pretty in the sky is because hydrogen and helium particles in the star's cores fuse together in extremely high temperatures, or what's simply called thermonuclear fusion. Stars form inside the dense, concentrated gases and dust scattered throughout galaxies. There are regions in space which have extremely cold temperatures, about -442 to -424 degrees Fahrenheit, or -263 to -253 degrees Celsius. Gas atoms bind together in these temperatures. The most common gases found in gas clouds are carbon monoxide and hydrogen gas. The coldness also causes gases to cluster to high densities. After reaching a certain point of density, stars form when the denser parts of the cores of gas clouds fall under their own weight or by gravity. The cores weigh 100,000 solar masses in the form of gas and dust. Because the cores are denser than the clouds, they collapse first. When the cores collapse, they break down into clumps about 0.1 piece or parsecs in size and 10 to 50 solar masses in mass. Twinkle, twinkle, little star, how I wonder how little you are. We may see stars as tiny silver dots from the ground, while in fact, stars are actually gigantic. They just appear small because they are a great distance away from Earth. The Sun, which we consider to be big, is the closest star to Earth and one of the smallest stars out in space. Stars also come in different colors that help detect how old a star is and how much longer will they last. There are blue, blue-white, white, white-yellow, yellow, orange, and red stars. This color order is from the highest temperature to the lowest. Blue stars are also the brightest and usually the youngest stars to exist. As they become older, they change colors, drop in temperatures, and lose luminosities and eventually turn into a cold dark matter. But that won't happen for a long time. Stars live for billions of years, possibly even longer. They are also classified according to their sizes. Stars are sorted as hypergiants, supergiants, bright giants, giants, subgiants, dwarfs, subdwarfs, and so on, also considering their colors and luminosities. The Sun is classified as a yellow dwarf. What makes stars more interesting? Constellations. Those are stars that are grouped together and form imaginary outlines and patterns of people, animals, or objects, usually associating mythological creatures and characters with them. Not all stars are a part of constellations, because no definitive star patterns can be formed in some areas in space. It's actually ancient people who thought of constellations. Stars don't really get to decide where they are going to be positioned, so these patterns are based from human creativity, trying to associate stars with their beliefs and culture. Animals in space. Did you know that the first beings from Earth that flew in space were not actually humans? Yes. Now let's take a look at the timeline of space exploration and the animals that have become part of it. The first animals from Earth that flew in space were actually fruit flies. In 1947, fruit flies were sent aboard the Nazi V-2 rocket, which flew around 108 kilometers or 67 miles away from the Earth. In 1949, Albert II became the first monkey in space when he reached an altitude of 134 kilometers or 83 miles. In 1950, a mouse was sent inside a rocket that flew around 137 kilometers or 85 miles before disintegration. The Soviet Union, on the other hand, used to fly stray dogs on suborbital flights. Laika the dog from the former Soviet Union is perhaps the most popular, as she became the first living being to orbit the Earth aboard Sputnik 2 in 1957. While in 1963, the French space program used Félicette the cat, making her the first cat in space. She flew at an altitude of 160 kilometers or 99 miles and was able to return to Earth safely. As of today, there are a total of 32 other monkeys who have flown to space, and there was even a turtle from the Chinese space program. And while you may think that sending animals to space is a novelty, they actually serve a greater purpose by providing scientists and astronomers valuable research and insights on the effects of space to living organisms, which in turn will make future space flights for humans and animals alike more safer. And that was another interstellar trip across the universe. Remember to join us next time for another mission to the cosmos and beyond. Only on Inside Outer Space.